In this question, it is given the rate constant of a reaction at 500 Kelvin and 700 Kelvin are 0.02 per second and 0.07 per second respectively. Calculate the values of activation energy and frequency factor. For this, we have to use this formula. It is log K2 by K1 is equal to EA by 2.303 into R, that is gas constant, into T2 minus T1 by T1 into T2. So here T1, T2, K2, K1 values are given, that is R is equal to 8.314 joule per Kelvin per mole, and T1 is that is K1 is 0.02 per second at T1 is equal to 500 Kelvin. When T2 is equal to 700 Kelvin, that rate constant is 0.07 per second. So K1 is 0.02 per second, K2 is 0.07 per second, and we have T1 and T2 values. Substituting these values in this Arrhenius equation and simplifying these values, we get EA value. For logs 0.07 by 0.02, we can change this value as log 7 by 2. And here 700 minus 500, we get 200. Then we convert this log 7 by 2 as log 7 minus log 2 according to the logarithmic formula. Then we cancel these two zeros and two zeros here, we get 2 by 700 into 5. Next we see the log value for log 7 and log 2 on logarithmic table. After log it is a one digit number, so we put 0 point, then we see log value on logarithmic table, that is 70 on 0, its value is 8451. Similarly, we see log 2, so it is a one digit number after log, so we put 0 point, we see 20 on 0, its value is 3010. So log 2 value is 0.3010. And simplifying this log values and simplifying this 2 by 700, we get 1 by 350, and this value is 0.5441. Next, multiplying these two values, we obtain 1750, and rearranging these two values on the denominator to the left side, we get this one. We can consider here 0.5441 as 0.544, and multiplying these values, we obtain 18,230.8 joules. This is the activation energy of the given data. Next, we have to find out A value or Arrhenius factor. For this, we use this formula, that is K is equal to A into e power minus A by RT. Here we have to take logarithm on both sides, we get this one. This value becomes minus EA by RT. And rearranging this equation, we get this one. Next, we have to take, that is, we convert this ln into natural logarithm, that is 2.303 log K plus EA by RT is equal to 2.303 log A. Here we consider this K1 value and the T1 value. EA value we already found it, that is a 18230. R value we know that. Next we simplifying this 0, 0. We get 1823 divided by 8.314 into 50, that is 50. Here 0.02 is changed as 2 into 10 to the power of minus 2. According to the logarithmic formula, we converted this one. Log 2 plus log 10 to the power of minus 2. Here we can consider 8.314 as 8.3 into 50 to get easy multiplication. We know that log 2 value is 0.3010, and here log 10 to the power of minus 2 is converted as minus 2 into log 10. Log 10 value is 1, so minus 2. So for this log 10 to the power of minus 2, value is minus 2. Here 8.3 into 50 is 450, and simplifying this two values we get minus 1.699, and dividing these values we get 4.393. Multiplying these two values we obtain minus 3.912 plus 4.393 is equal to this one. Next, subtracting these values we obtain 0.481. Here bringing this 2.303 on the left hand side, we get log A value. After the decimal point, three numbers are present on both numerator and denominator. So we can consider this fraction as a whole fraction, that is 481 by 2303 is equal to log A. And this value is, simplifying this value is, we get 0.2088 is equal to log A. To find A value, we have to take anti-log on both the sides. So next we see the anti-log value for 2088 on anti-logarithm table. So here 20 on 8 and 8. 208 values 1614, and this 8 values 3. So adding these two values we get 1617. So before the decimal point 0 is present, so we put a decimal point after one number, that is 1.617 is equal to A. This is the frequency factor or Arrhenius constant value.